In this video, we're going to take a look at how to perform what's called synthetic division. Now, synthetic division is a short form for long division of polynomials. In the previous section, we had looked at a polynomial divided by a monomial, like I think we had done something like 6x or something like that in the previous video. So this was divided by a monomial. Now we're going to take a look at a very specific kind of problem. We will only consider synthetic division when dividing by a binomial of the form x plus k specifically. So what we're going to do is, first we're going to learn the proper requirements for using synthetic division. So I've got a few examples here. In each case, the numerator is exactly the same. 1, 2, 3, 4 different problems here that is basically division. But in this particular case, we cannot use synthetic division. And the reason here is this denominator, x squared plus 2, is not x plus k form. And the reason being is it's got this power of 2. So we wouldn't use synthetic division in this particular case. In the next case, we also wouldn't use synthetic division because our denominator, 2x plus 3, is not x plus k. Specifically, it's not got a 1 out in front. So that leading coefficient on our divisor needs to be 1 as well. That's sort of bad for us. Now, in the next example, we would use synthetic division. Check. This is of the form x plus 3 is of the form x plus k, where k is the numerical value 3. Finally, in this bottom example, this one's actually okay too. This divisor, x minus 4, is of the form x plus k, where in this case, k is actually the number negative 4. So second guessing myself there for a second. That is to say, x minus 4 is x plus negative 4. So it does have that format. Specifically what we're looking for here when we're dividing is a lead coefficient of 1 and a power of 1 on x. That's what we want in order to use this division. Okay, next we're going to learn the proper setup or format for using synthetic division. Now this is a little bit different from long division. The first thing that we're going to do here, in this case, let me switch colors, is we're going to use columns and placeholders. So we have this little backwards crook here, and in there goes the opposite of our k value. So if k is 3, this is the opposite of k, negative k. So in this particular case, we would put a negative 3 there. So this is k equals 3. And so we put a negative k in that spot. Next, what we use here is just the coefficients of the polynomial. So our coefficients are 3, 7, negative 2, and negative 4. So 3, 7, negative 2, and negative 4. And then we put a horizontal bar 1 row down. And that's the proper setup here. We're going to talk about the execution in a minute. So really what's going on is we just have the individual coefficients from our dividend, the polynomial that we're dividing into, and what's most important here is we're using the negative k value, the opposite of that k value. So down here in this next setup here, we have our crook setup. We still have the same coefficients on our polynomial, 3, 7, -2, -4. But this time down here, our k value is -3, and so when we put our k value into our crook here, it's going to be the opposite of -3, which is going to be +3. So watch out there. Again, whatever we're dividing by, we're using the opposite of the k value. And then, of course, we would have our horizontal bar one row down. Now that's just the setup. We're not executing it yet. This last one here is not the same coefficients. So let's see. We'll have our crook. Our k value is 3. And so -k will go in there. This will be another -3, just like up top there. And our coefficients are 3, 7, and watch what I do here. This is a 5 over here. As we got in columns here, this is the x cubed position. This is the x squared position. This is the x position, and this is the constant position. And the same is true in the step below, or the example below. And the same should be true here as well. So what do we need? Well, just like we had talked about before, we need a placeholder. And if you don't have a placeholder here, you're going to run into some serious trouble when you're trying to perform this synthetic division. So that's a big deal for us, the placeholder. So let's highlight that, and let's highlight our differences. So the big ideas here is this first one is pretty straightforward. These are the coefficients of the numerator. Here, we're using the opposite, or negative k value, for our divisor. That's key there. And then in this last version here, what's key is the use of placeholders. All right. That's a little key there. So watch out. Okay. Finally, we learn how to execute the process of synthetic division. Now, I have drawn this setup 4 times here, and we might have to go a little bit more than 4, but you're not going to have to draw this 4 or 5 times when you do the problem. I'm just doing this for illustrative purposes on the notes to show you step by step. So here's how this process goes. Step number 1. Bring the lead coefficient down below the bar, like this. And I'll put a little arrow here, and we'll put a 3 there. So that's our first step. Next, step 2. Let's see, I already got a 3 there. Let me do this next step in a different color. Step number 2, multiply negative k by the value below the bar and place the result in the next open position above the bar. So, what are we talking about here? Well, we're talking about multiplying. That's negative 3 times 3, and the result is going to be a negative 9. Okay. So what do we have here? We have a 3, and we have our negative 9. Step number 3. Add the column values and put the result below the bar. So what are we talking about now? We're talking about these two values here in this column, and we're talking about adding them together. So 7 plus negative 9 is a negative 2. Looks like I'm going to have to duplicate this a couple more times. Okay. Let's see, another color here. What do we got? Oh, that's hard to look at. Let me choose a different color. Step number 4. Repeat steps 2 and 3 until all columns are filled out. So what would that look like? Or what do we have? So we have, get my colors out here. We had dropped the 3, we had multiplied the 3 by the negative 3 to give us negative 9. We had added those together, and we had got negative 2. And now we're supposed to repeat that process. So let's see here. We're now going to take negative 3, multiply it by negative 2, and that's going to give us our next result. So let's see here. Negative 3 times negative 2 is a positive 6. And then we'll add those together. And the result will be a 4. It's a little hard to color code this. Let's see. This was a 3. This was a negative 9. This was a negative 2. This was a 6. This was a 4. And we'll repeat this process. Take negative 3, multiply it by the value below the bar, and place the result in the next open position. So let's see here. Negative 3 times 4 is negative 12. And then finally we'll add those together and we'll get negative 16. Now, once that's done, we're going to place another little crook here around this last value to separate it from the other values. And we're done with the synthetic division. So what's left? I said finally we need to learn how to do this, but we also now we interpret our results. So first things first, let me actually duplicate this. And let me erase some of these markings. There we go. Perfect. So that's what the completed synthetic division looks like. And first things first here, this is what's called the remainder. This is the remainder. from the division. So we might say something like r equals negative 16, r for remainder. And these next values are the values of our coefficients. So these are the coefficient and constant values of the quotient from the division. What do I mean by that? Well, I mean the result here is, starting from the far left, next is, first, so this is our remainder. Let's see here, we already talked about that. Here's our remainder. This is our constant term. This is our coefficient on x. And this is our coefficient on x squared. And so the result here is 3x squared minus 2x plus 4 with a remainder of negative 16. So what are we talking about? Well, if you remember the original problem was 3x cubed plus 7x squared minus 2x minus 4 divided by x plus 3. And that is equal to 3x squared minus 2x plus 4 with a remainder of negative 16. Now, this particular notation here is a little bit childish. That's the kind of thing that you do when you first learn how to do synthetic division, when you learn how to do division in, arithmetic, or I'm not sure when everybody learns that, elementary school, junior high, high school, depending upon when you learn that kind of thing. What am I talking about? Well, if you were to do something like 9 divided into 432, let me change that because 9 actually goes into that evenly. Let's do 435. You would do something like, well, 9 doesn't go into 4. 9 goes into 4 0 times. But 9 goes into 43 4 times. 4 times 9 is 36. Parentheses, subtract. And you would get 43 minus 36 is a difference of 7. And then you'd bring down the 5 and you'd repeat. 9 goes into 75 8 times. 8 times 9 is 72. Subtract, and then you'd get a 3. And then, if this was elementary school or whatever, some people would write remainder 3. But what you really mean is 435 divided by 9. 9 goes in 48 times, and there are a remainder of 3 out of 9 units, 3/9. Or you might write something like 48 1/3 if you simplified that. So what we're really talking about doing is instead of using this R16, we want to rewrite it in terms of our remainder over our divisor. So in this particular case, when we're talking about long division or synthetic division with polynomials, we actually want to write something like this. 3x cubed plus 7x squared minus 2x minus 4 divided by x plus 3 is 3x squared minus 2x plus 4 plus a remainder of negative 16 over x plus 3. So again, we have our remainder over our divisor there. So again, remainder over divisor. And that's how you perform synthetic division.